Now, in this section, 8.3, we're going to be talking about slopes. We previously graphed linear functions whose graphs were straight lines. Every non-vertical line has a slope that has a ratio of rise, which is a vertical change, to run, which is a horizontal change between 2 points. So we have been talking about ratios. So this ratio is going to be rise over run. So in this example that we have a slope. And we've noted 2 points on the slope. A, which has the coordinates of -3, 3, and B, which have the coordinates 1, -3. Now, we're going to determine what is the slope of that line. So as our formula says, we're going to start with one of the points and determine our rise over our run. So starting with B, I'm going to go up 1, 2, 3, 4, 5, 6. 6 will be my rise, and that is a positive number. Then I'm going to run 1, 2, 3, 4, and I did that in the negative direction. So my rise is 6, my run is -4, but as always in this ratio we are going to simplify it to 3 over -2. So note we took from B, we went up 6 positive and to the left a -4, and then we simplified that to be our slope for this particular function is -3 over 2. You can put the negative either in the numerator or denominator, and it means the same thing. Okay, now in this lesson you're going to become familiar with 4 different types of slopes. A is a positive slope. It goes in that direction. You'll be asked to label what type of slope is this? Positive. B is a negative slope. C is a slope of 0. There is no slope at all, so you just say a 0 slope. This would be your answer when asked. And then D is an undefined slope or no slope. You will be asked to label these type of slopes. So you need to be able to determine if it's a positive, negative, 0 slope, or undefined. Number 4, to find the slope of a line, you find the ratio of the rise over the run between 2 points of the line. Now I'm going to label these 2 points. So in A, 4A, I plotted those 2 ordered pairs or relations. Now let's determine what the slope is. Remember, rise over 1 over run. So just take either one of the points that you can. You can either use, let's label them. Let's label this A and this B. I'll pause the video and come back and see if you can tell me what the slope is for this line that we drew. Okay, in the green, we started with B and we went up to 1, 2, that is our rise, and then we ran a +4. 1, 2, 3, 4. So we had 2 over 4, and we simplified that to 1/2 and noted that it was a positive slope. But another way that you could determine it is start with A. So we ran 1, 2, 3, 4, a -4. That's where I have my blue. And then we rose or went down -2. That's going to be my numerator. Since they were both negative, they cancel each other out, which also equal 2, 4. So it is the same slope no matter which point you decide to use. Probably B would be the simplest point to start with, but in case you can't determine what it is, you can use it from any point. All right, let's do B. Draw a line that draw the line that has a slope of -3 and passes through 2, 5. So you'll notice I plotted 2, 5, and from that point I went down -3 over a +1. So the slope is a -3. So in example 5, we are going to plot the ordered pair of 3 and 0. And then it asks us to have a slope of 1/2. So I'm going to rise 1, run 2, 1, 2. I'm going to rise 1, run 2. See, there it is still. If I wanted to go backwards and do a -2 and go down 1, that would be 2 negative and it'd still be there. Rose 1, run 2. So there you've plotted a slope of 1/2 from the given point 3, 0. So I can take anywhere on this line. Let's take this part right here and count with me, class. We're going to rise 1, run 2, 1, 2, and there it is. Rise 1, run 2. So any place on that line, the slope is 1/2. You can pick 2 easy points. Like I picked the one, I can pick a point here, rise 1, 1, 2, and that's why I'm there. Because I can pick it's easy if I have a start at intersection of the X and Y axis. Okay, so now we'll be having word problems and the graph. The graph represents the distance traveled by lava flow over time. Find the speed of the lava flow. Now this is in your textbook on page 410 if you'd like, but I put the graph up here for us. Remember, we have slope is rise over run. Note in our graph that the distance is going to be the y-axis. The time is going to be the x-axis. So you'll notice that we have the distance as our numerator, the time is our denominator, and if we needed to put that in unit rate, we had 6 miles going in 4 hours, or you go 1.5 miles in 1 hour. So when you have these type of problems that you've got to determine your ratio, your rise is going to be your distance. Your run is going to be the amount of time. And you're going to have to put that in a unit rate. Okay, in our next example, we are going to plot the points 3, 4, 6, and 3. Then we're going to find the slope of the line that passes the point. So that's the first bullet that we're going to do. So I'm going to ask you on your notes to plot 3, 4, 6, 3, and we're going to determine what the slope is of those 2 points. So from these 2 points, you rose 1, you ran a -1, 2, 3. So the slope of these 2 points would be -1/3. Now if they were both negative, then they would cancel each other out and be a positive slope. But this is a negative slope. You remember what we did earlier? When it goes in this direction, it is a negative slope. Those are the one of the 4 that you'll be noticing. Okay? In example 6, when we were talking about the previous lesson, we were talking about lava flow. Suppose a line starts at the origin and passes through the point 3, 6. Find the speed of the lava flow. What do you do? So in example 6, we said, suppose that the line starts at the origin and passes a point through the point 3, 6. Now, as you can recall, this is our origin. And it passes through the point 3, 6. So I'm going to go 3 and 6. And I plotted this point right here. Then it asks, find the speed of the flow. And we're going to determine that by rise over the run. And in order to determine what the flow is, we're going to take the distance over time. So our distance, as you can see, is 1, 2, 3, 4, 5, 6. So here is our distance. And then our time, which is 3, 1, 2, 3. So we have 6 miles in 3 hours, and you can determine that by 2 miles per 1 hour. Now, we have 2 last practice examples. Number 8, draw a line that has a slope of 1/3 and passes through 2, 5. So in this first example, I drew a line that has a slope of 1/3 and passes through 2, 5. So I plotted 2, 5, and then from that I rose 1, ran 3. So that is number 8. So in number 9, we plot the points -3, 1, Then it wanted a slope of -4. So from this point of -1, 3, we went down 4, 1, 2, 3, 4, and over 1. Noticing that if it's a slope of -4, it would be -4 over 1. And notice the way the direction of the line is. It's a negative slope.